this module, you will learn about the different operations that can be performed on sets. While we come across many sets in mathematics, it is evident that many sets share the same elements. We can perform various operations on sets. Examples of operations are union of sets, intersection of two or more sets, difference of two sets, and complement of a set. Let us learn these operations in more detail. Let P and Q be two sets. The union of sets P and Q is a set that consists of the elements from both the sets. Let's perform the union operation over sets P and Q. The elements of sets P and Q are listed out one by one. The repeated elements are written only once. Here, 5 in both the sets is written only once. Hence, set P union Q consists of all the elements of sets P and Q. The definition of union can be as follows. The union of two sets A and B is set C, which consists of all those elements that are either in A or in B. Symbolically, the union of sets A and B is represented as shown. The Venn diagram representation of two sets A and B is as shown. The shaded region represents the union of the sets A and B. Observe that both the circles are shaded since set A union B consists of all the elements of sets A and B. Some of the properties exhibited by the union of two sets are as listed. The union of two sets follow the commutative law. The union of three sets follow the associative law. The result of the union of a set with a null set is the set itself. The union of a set with the same set follows the idempotent law. The union of a set with the universal set results in the universal set itself. Let's discuss the intersection of sets. Let's consider the same sets P and Q, which we saw before. If we consider the set of common elements of sets P and Q, then we can say that the set is formed by P intersection Q. In sets P and Q, the common element is 5. Therefore, the intersection of sets P and Q is 5. The definition of intersection is as follows. The intersection of two sets A and B is the set of all those elements that belong to both A and B. Symbolically, the intersection of sets A and B is represented as shown. The Venn diagram representation of intersection of two sets A and B is as shown. The shaded region represents the common elements belonging to the two sets. Here is an interesting property of the intersection of sets. Let's consider two sets C and D. We can observe that there is no common element among the sets C and D. Therefore, C intersection D is a null set we can say sets C and D are disjoint sets. The Venn diagram representation of sets C and D is as shown. Some properties of the intersection of two sets are as follows. The intersection of two sets follow the commutative law. The intersection of three sets follows the associative law. The intersection of a set with a null set results in the null set. The intersection of a set with the universal set results in the set itself. The intersection of a set with itself follows the idempotent law. Intersection is distributive over union. This property can be verified with the help of Venn diagrams. Taking the left-hand side, for B union C, we have this Venn diagram. A intersection B union C is as shown. On the right-hand side, the Venn diagram for A intersection B is as shown. The diagram for A intersection C is as shown. For A intersection B union A intersection C, the Venn diagram is as shown. Next, we will discuss about the difference of two sets. Consider two sets X and Y as shown. The difference of sets X and Y taken in the same order is denoted as shown. The difference of sets Y and X taken in the same order is denoted as shown. First, we will find the difference of sets X and Y taken in the same order. This means we have to find the elements that are present in X but not in Y. The elements that are in set X but not in set Y are 2, 3, and 4. Therefore, set X minus Y has the elements 2, 3, and 4. Next, we find the difference of the sets Y and X taken in the same order. This is found by taking the elements that are present in Y but not in X. These elements are 7 and 8. We can observe that X minus Y is not equal to Y minus X. Set X minus Y is represented through a Venn diagram as shown. Observe the shaded portion. Only the region of set X, which is not shared by set Y, is shaded. Similarly, the Venn diagram for Y minus X is shown here. Only the region of set Y, which is not shared by set X, is shaded. The difference of any two sets, A and B, taken in order, is represented symbolically as shown. Similarly, B minus A is written symbolically as shown. The concept of the difference of two sets can be extended by replacing one of the sets with the universal set. Let's see an example to understand this. Let us consider the set of natural numbers. We can consider the set of whole numbers a universal set for the natural numbers. The difference of sets W and N is the complement of set N. The complement is denoted as shown. Therefore, the complement of set N with the universal set being the set of whole numbers is a singleton set with 0 as the element. Let U be the universal set and A be a subset of U. Then, the complement of A is the set of all elements of U that are not the elements of A. The complement of a set A is symbolically represented as shown. The Venn diagram representation of the complement of a set is as shown. The shaded region represents the complement of set A. It should be noted that the complement of a set depends on the universal set. For example, let's find the complement of the set of natural numbers with the universal set being the set of integers. The complement of set n is shown here. A few observations on complements of sets. If A is a subset of the universal set U, then its complement A' is also a subset of U. The complement of the union of two sets is the intersection of their complements, and the complement of the intersection of two sets is the union of their complements. These are called De Morgan's laws. The complement laws are as follows. The law of double complementation says that the complement of any set is the set itself. The laws of empty set and universal set are as shown.